The arrangement of the planets in our solar system has been a subject of fascination and study for centuries. Each planet occupies a unique position, determined by complex gravitational interactions over billions of years. This precise arrangement has profound implications for the characteristics and behaviors of the planets, as well as for life on Earth. But what if the planets were to change positions? This hypothetical scenario offers a fascinating exploration into the dynamics of our solar system and the potential consequences for each planet and life as we know it. Our solar system consists of 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, in order of their proximity to the Sun. Each planet's position is crucial for its climatic conditions, atmospheric composition, and potential to harbor life. For example, Earth's position in the habitable zone allows it to maintain liquid water, an essential ingredient for life. Jupiter's massive size and gravitational pull play a critical role in protecting the inner planets from frequent asteroid impacts. Imagine a scenario where the planets swapped positions. This radical change would have dramatic effects on each planet and the overall dynamics of the solar system. Mercury, being a small, rocky planet with a thin atmosphere, would struggle in Neptune's distant, frigid orbit. Its surface temperature would plummet, leading to a frozen, inert surface. The lack of a substantial atmosphere would prevent any significant retention of heat, making it one of the coldest objects in the solar system. Venus, with its thick, toxic atmosphere of carbon dioxide and sulfuric acid clouds, would undergo significant changes in Uranus's colder orbit. The greenhouse effect, which makes Venus the hottest planet, would be diminished. While it would still be inhospitable, the temperatures might drop to more moderate, still extremely cold levels. Earth would face a dire situation in Saturn's orbit. The increased distance from the Sun would lead to a significant drop in temperatures, likely causing the Earth's surface to freeze. The shift would also impact the planet's day length and seasons, possibly making life as we know it unsustainable. Mars, currently a cold desert, would gain a thicker atmosphere due to its closer proximity to the Sun in Jupiter's place. However, it would still struggle to retain heat and might face violent weather patterns due to its lack of a strong magnetic field and its thin atmosphere. Jupiter would become a dominant force in the inner solar system, its massive gravity potentially destabilizing the orbits of the inner planets. Its intense radiation belts would pose a significant threat to any nearby planets, potentially stripping them of their atmospheres. Saturn, in Earth's habitable zone, would still be a gas giant with no solid surface to support life. However, its moons, such as Titan and Enceladus, could potentially warm up enough to develop more complex chemical processes, possibly even life. This new arrangement would drastically alter the gravitational dynamics of the solar system. Jupiter's presence in the inner solar system could destabilize the orbits of other planets, potentially leading to collisions or ejections of planets from the solar system. The redistribution of planetary masses would also affect the Sun's gravitational influence, possibly altering its behavior slightly. Moreover, the asteroid belt might be disrupted, sending a shower of asteroids toward the inner planets, posing a significant risk of impacts. The Kuiper Belt and Oort cloud, regions filled with icy bodies and comets, could also be affected, potentially increasing the number of comets entering the inner solar system. This exercise in imagination reminds us of the intricate and interdependent nature of celestial mechanics and the special conditions that have allowed life to flourish on our Earth.